What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
If we start talking about proper names in an automobile, we should start with the engine. Dozens of names and brands are coded here. There is a whole mountain of named thermodynamic cycles of engine operation alone, and among those that are still on the rumor, we can recall the Otto cycle. It actually became classical, Atkinson and Miller. But one of the key figures in the history of the internal combustion engine, who divided it into before and after, was Rudolf Diesel. Diesel is a man whose life has consisted almost entirely of mistakes and failures. First, he had the misfortune of being born in the mid-19th century, shortly before the Franco-Prussian War, which caused him, an ethnic German living in France, to have to swing around Europe at a young age in search of a quiet life and a proper education. Then, when it came to work, he first set about perfecting a steam engine, but one of his test subjects didn't reciprocate, but an explosion that nearly killed Rudolf. Then Diesel developed the concept of an engine with a thermal efficiency of more than 70%. For comparison, the index of steam engines of those years was about 20%, and the most modern gasoline engines have a thermal efficiency of about 40%. Or rather, Diesel himself believed that he had developed it. It soon became clear that the inventor did not take much into account. The pressure in the combustion chamber of about 100 atmospheres meant monstrous friction losses to seal the chamber, and the calculated ratio of fuel to air in the proportion of 1 to 100 would not allow the mixture to burn at all, so he spent several more years of his life to realize and correct his mistakes. And even the invention of a workable and commercially successful diesel engine brought him not world fame and fabulous income, but patent litigation and health problems. And in 1913 he went by steamship to the opening of a new plant for the production of diesel engines, but disappeared right off the ship, and even his body was never found. All in all, it was a hard life, and by the way, it is curious that even one of the key features of the diesel engine was of little interest to Diesel himself. It is about compression ignition. If in a gasoline engine the mixture is ignited by a spark plug, in a diesel engine it is ignited by itself due to the high compression ratio. But for Rudolf this was not important. According to his own statement, he did not patent compression ignition and did not even set out to achieve it. But it turned out the way it did. By the way, it turned out quite well, so much so that the diesel engine in modern motor construction was loved for a long time and was predicted to be almost more successful than the gasoline one. However, at some point it was sharply disliked, and now some companies generally refuse from further development of new diesel engines because of tightening of ecological nuts. In general, if Rudolf Diesel had lived up to our days, he would die of grief now. It is necessary to ruin such an invention. It is also worth noting that in addition to those who worked out the cycles of the classic piston internal combustion engine, there were those who offered fresh ideas for its design. And if the creations of Burke or Stelzer are known to a few, then, for example, Wankel's engine will be confidently named by many. And someone will even tell its device and principle of operation. But all the same, even Wankel is far from Diesel in terms of popularity and world fame. Now let's move from the general to the particular. That is, from the whole motor to its individual components. For example, while someone thought up how to get maximum work from the motor with minimum fuel and losses, someone thought over how to start this motor at all. But if the name of the inventor of the starter is lost in the centuries, and we have reached us just a tracing of the English word starter, then the constituent part of the starter in the people received a more specific name, Bendix. And this mechanism has a quite official technical name, overrunning clutch. Why is it nicknamed Bendix? You have already probably guessed. In honor of its inventor, Vincent Bendix. Vincent, at the start of his career, was little more fortunate than Rudolf Diesel. At least he wasn't born in the middle of a war, and he was born in the United States, not Europe. But his first business was still unsuccessful. Bendix Corporation, founded by him, aimed at the production of cars, closed after 2 years and 7,000 produced cars. However, Bendix was not disappointed and a couple of years later invented the inertial drive starter. In this way he solved the problem that the inventors before him had created for themselves. They had invented an electric starter drive instead of a crooked one, but they had not figured out how to pull the starter pinion away from the flywheel gear. The essence of the problem is simple. Initially, a stationary flywheel is spun by the starter through the drive pinion, but after starting the engine, the flywheel begins to rotate much faster, and during the time when the starter pinion tries to part with it, it spins the starter to complete collapse. To everyone's delight, Bendix built a design with springs and, most importantly, the very overrunning clutch, which allowed to avoid back rotation of the starter by the flywheel. The essence of the overrunning clutch is to transfer torque from the drive shaft to the driven shaft, but not to allow the driven shaft to spin the drive shaft. Its simple design is easier to understand at a glance at a picture than to describe in words, and the simplest example is the ratchet mechanism, which is familiar to many. Not surprisingly, since the beginning of the 20th century, when Bendix sold his patent, the starter design itself has undergone some changes, but the overrunning clutch as a device to prevent the starter from being overrun by the flywheel has remained with us to this day. By the way, Vincent Bendix himself also benefited from the sale of the patent. As a talented and versatile man, he later became involved in brakes, and then went into aircraft construction. But we'll talk more about brakes. They have their own famous names. But for now, since we are talking about electrics, let's remember another element that bears the famous name, the Hall sensor. To begin with, it's worth understanding that Hall did not invent or manufacture these sensors. In fact, a Hall sensor is any sensor that utilizes the effect of transverse potential difference, and it was this phenomenon that Edwin Hall discovered. All this had nothing to do with automobiles at first. At that time, in 1879, there were no automobiles at all. But then, much later, the Hall sensor became an integral part of them. Now they are mainly used as camshaft and crankshaft position sensors, but earlier they were also used in electronic ignition systems. Mr. Hall could hardly imagine how useful, versatile, and long-lived his discovery would turn out to be when he was writing his doctoral thesis. But a day in the present day would have made him happier than Rudolf Diesel. But Isaac Babbitt, in his native USA he was called Babbitt, reasons for upset minimum, and not because he died back in 1862, but because the alloy that he invented, to this day remains relevant as an anti-friction material. The alloy, in general, is simple. It consists of 80 to 90% tin or lead, and the additives are mostly copper and antimony. The only reason for Isaac to be upset is that in automobiles Babbitt still gave way to other, more modern alloys and materials. However, why be surprised? Because the invention is already more than 180 years old. Today, we remember Babbitt as part of history. The most famous example is the Babbitt liners of the famous of a gas-powered gondola. That drove everything and everyone during the Great Patriotic War. Isaac Babbitt himself all his life loved to cast, alloy and weld, and therefore the name alloy was his main, but not the only achievement. For example, in the United States, he made history by casting the country's first brass cannon. In addition to metallurgy, he was also successfully engaged in soap making. Transmission and running gear. Another huge layer of eponymic names is the undercarriage. The principle of Ackerman and Rzepa's ball and socket joint is something that we do not remember immediately, but the names of McPherson, Panner, and Watt are very much on our lips. All of them tried to achieve stability, controllability, and comfort from the car, and all of them, especially McPherson, we are grateful to them to this day. However, let's go in order. McPherson is the first profile engineer in our history who developed his creation not accidentally or casually, but purposefully. It happened to him in the late 40s of the last century, when he worked at GM. True, GM did not have time to appreciate the invention. McPherson developed a front suspension for a new compact and cheap Chevrolet Cadet, and the project was cancelled. So the engineer with all the developments went to Ford and there started to install his suspension in new models, first Vedette, and then Mass Zephyr, Consul, and so on. Just in case we remind you that the essence of the McPherson rationalization is not the use of a shock absorber strut consisting of a shock absorber inside a spring. Or rather, not only that. The spring and the shock absorber can exist separately, but the essence is the departure from the double transverse arms, which prevailed for many years, in favor of a simpler design with a single arm at the bottom and the shock absorber, resting on top of its own joint. The McPherson suspension is not only simpler, but, accordingly, more compact, lighter and cheaper in mass production. In addition, its invention paved the way for cars with transverse engine arrangement. Compact design allowed to expand the engine compartment, and at the same time to reduce the length and weight of cars. This paved the way for its popularity and its inventor's almost eternal fame. Modern engineering students have a lot to learn from him. One worthwhile innovation can make you famous for hundreds of years to come. And here is one of the inventions of Frenchman René Pannet, a clear proof that it is not necessary to invent a complex design to immortalize your name in history. No, in general, of course, Pannet was a talented engineer and a successful businessman, as well as a pioneer of the French automobile industry, who founded with his partners the Pannet-Levasseur Company for the production of passenger cars with internal combustion engines designed by Gottlieb Daimler. But his solution applied in the suspension is ingenious in its simplicity. As you know, the essence of suspension is to hold the vehicle and dampen body vibrations caused by road irregularities. The suspension, therefore, must move vertically relative to the body, but longitudinal and especially horizontal movements are contraindicated. Well, decided Panner, if contraindicated, then let's just connect the suspension with the body-rigid rod with joints at the ends. And you know what? It worked. True, with some nuances. Since the rod is rigid and attaches the bridge to the body at one point, when the bridge moves up and down, it still moves around the circle, the radius of which is the Panara rod itself. That is, by solving the problem of transverse displacement of the axle relative to the body, Panner created the problem of transverse displacement of the axle relative to the body. Albeit to a much lesser extent, but still, on cars with narrow track and long suspension travel the displacement will already be very noticeable. James Watt came to the aid of Panner and automobile builders. Or rather, memory and logic came to their aid. Watt had invented and patented his mechanism 100 years before Pannet, only it was intended for the connecting rod of a steam engine piston. If Panner's rod was one, Watt's is more serious. There are 3 times as many levers. The scheme of fastening is the same, diagonal, but the joints here are not 2, but 4. 2 rods are attached to the body and their bridge, respectively, and connected to each other through a 3rd short lever, which, in turn, is mounted on a hinge in the center of the bridge. All this allows the axle to move vertically, but does not allow it to shift longitudinally. Well, almost does not allow. The graph of the bridge center movement in this game is also not a perfect vertical straight line, but a kind of integral, but it is still many times better than a circle in the case of the Panner scheme. However, Panner and Watt designs still exist to this day on almost equal footing. Sometimes one lever is not much worse than 3. The next stop on our way is transmission. Not everyone will immediately remember who Rzepa, Weiss, and Lobro are, and even more so the names of the founders of the GKN company. And in vain. If it were not for them, we would drive now on rear-wheel drive and with gimbal, for which, however, thanks to Girolamo Cardano, who described their design in the 16th century. Cardano did not guess that in the future almost every second car will have a transmission of his name. And he hardly guessed what an automobile was either. However, he described the principle of torque transmission by 2 shafts, which are at an angle to each other, just in case. His work was continued by other scientists and designers, in particular, Hooke and Spicer. So the traditional universal joint with a cross pinion is also called Hooke's joint. But the cardanic gear has an important disadvantage. It does not provide synchronous movement of the shafts, and the higher the angle between them, the stronger is the unevenness of movement. This disadvantage was partly eliminated by simply doubling the number of joints. The dual gimbal was already a constant velocity joint. But the problem of reliability when working at large angles between the shafts did not go away. So engineers around the world had to work to invent a universal joint, U-joint, free of this problem. Engineers worked independently of each other and constantly invented similar, but different designs. Transitional link in the evolution between the cardan and modern ball joints was the joint of Carl Weiss, patented in the early 20th century. It already had grooves and balls, but the torque was transmitted by only one pair of balls in each direction of rotation, which did not promise outstanding reliability. However, the beginning had already been made. The balls rolled and everything turned. This is how the joints of Reception and Beerfield, as well as those of GKN and Lobro, which is now owned by GKN, were born, with different working conditions. But, apparently, no matter how perfect and imperfect the joints become, the cardan drivetrain is with us forever. And while some were thinking about how to transmit torque while minimizing friction losses, others were working to maximize friction. Where does it matter? Well, If we leave tires out of the equation, then at least in two systems, clutch and brakes. That being said, both of these areas have the most famous friction name in the world, Pherodo. This word has come to denote the friction material used in the clutch and brakes. The manufacturer, as you can easily guess, was the Pherodo company. It was founded at the turn of the 19th and 20th centuries by Herbert Froude, an English inventor, industrialist, and merchant. He was one of the first people, if not the first, to look at the braking systems of those years and to use not only his eyes but also his head. Typically, brake manufacturers back then had a critical problem to solve: how to apply the brake to the wheel to stop the wagon faster. Froude, on the other hand, figured out that in addition to pressure in the contact patch, friction was critical. The old saying goes that you can do more with a good word and a gun than just a good word, and Froude realized that by increasing the coefficient of friction in a brake pair, you can do much more than just applying the brake to the wheel. This simple conclusion was the starting point for the creation of a very successful business. In the USSR, the word Pherodo was primarily associated with the clutch, although the main focus of the company's work was still brakes. Froude first developed brake pads made of cotton and bitumen, and a few years later, much more effective pads made of asbestos impregnated with phenol formaldehyde resin. The latter can already be considered quite modern in characteristics. They held high temperatures well and showed decent results in friction properties and wear resistance. Sometime later, this material tried and in the production of automotive clutch, and the company Pherodo began to produce including products for these systems. However, by the end of the 20th century, people have paid attention not only to thermal and wear resistance, but also to carcinogenicity of asbestos and toxicity of phenol formaldehyde, so that since 90th years their manufacture and application gradually decreased. And in the beginning of the 21st century, materials containing asbestos gradually began to forbid in Europe, the USA, and so on. However, Pherodo could not be fatally harmed by this. It produced the first asbestos-free pad back in the 80s. Having vast experience, it switched to the development and production of alternative friction materials, and also continued to expand the range of products, adding other parts of the braking system like discs and brake fluid. And in the late 1990s, the Pherodo company became part of the Federal Mogul Corporation. By the way, today Pherodo can afford to care not only about the efficiency and environmental friendliness of brakes, but also about their aesthetics. For example, in addition to sports pads of Racing Series and high-performance Premier Series, the company produces brake discs with anti-corrosion coating Pherodo Coat Plus. The name quite clearly describes the essence. If you are annoyed that new brake discs after a few months begin to rust, and a year later look frankly sad against the background of serviced and clean brakes and beautiful alloy wheels, Coat Plus will ease your suffering. Conclusion: not every inventor or manufacturer is able to establish their name in a product. To do so, the product must be either fundamentally new and viable, or the best among competitors. So all the names listed above are the clearest evidence of success and a reason for the manufacturer to be proud. And those who produce products from the distant past to the present day, like Pherodo, can be proud not only of history, but also of production traditions, proven quality, and the reputation of a premium manufacturer among customers. In conclusion, the world of automotive innovation is rich with stories of inventors and companies whose names have become synonymous with essential car parts. From the pioneering work of Rudolf Diesel to the precision engineering of Pherodo, these individuals and organizations have left an indelible mark on the industry. Understanding the origins of these names not only deepens our appreciation for the technology that drives our vehicles but also highlights the creativity and ingenuity that continue to shape the future of automotive design. As we move forward, let us remember the legacy of these innovators and the impact they have had on our everyday lives. Thank you for joining us on this journey through automotive history.